All right, so trigonometry is the study of triangles. Okay, so don't talk while I'm talking. All right, so what's going to happen is a trig ratio. It's a ratio of the lengths of the two sides of a right triangle. Okay, so we're just going to take two sides of a triangle and we're going to make a ratio out of it, or a fraction. Okay, we have three different ones. We've got sine. We abbreviated SIN. We say sine, not sin. Okay, cosine. We abbreviated COS. We still say cosine, not cos. Right, and then tangent. We abbreviated as TAN. Okay, so those are some of the abbreviations that you're going to see when we are doing these. All right, so the biggest thing that we need to discuss is what's the hypotenuse, what's the adjacent side, what's the opposite side. So it all depends on what angle you are looking at. Okay, I think we've gotten fairly decent at knowing what the hypotenuse is, right? That's going to be always going to be the side that's opposite your right angle, right? Okay, so when we're talking opposite and adjacent, okay, if I'm asking for A, I'm looking at angle A, okay? If we're talking about opposite, we're talking about the side that's across from angle A. Okay? If we're talking about the adjacent side, we're talking about the side that's next to it or hooked onto it. Okay? It would be opposite if we're talking about B, because then I'm looking at B up here. My side that's opposite B would be side B, right? And my side that's adjacent to it or hooked to it would be side A. So it all depends on which side or which angle we are looking at. All right. So to be able to find the ratio of sine, sine is opposite over hypotenuse. That's how you find the sine ratio. So it's opposite over hypotenuse. Cosine is adjacent over hypotenuse. And tangent is the opposite side divided by the adjacent side. Okay, so if we look at our triangle, and if I want sine of A, so now I'm looking at A, sine is going to be opposite, which is what side? A, over hypotenuse, which is C. So sine of A would be A over C. Cosine of A, cosine is the adjacent side. What side is adjacent to A? B over our hypotenuse, which is C. Okay, and then our tangent is opposite, which is A over adjacent, which is B. Good. Questions on what we mean by opposite and adjacent? No? All right, so now if it says sine B, that means we're looking at B. In relationship from angle B, sine is opposite, which is B, over hypotenuse, which is C. Cosine of B is the adjacent, which is A, over hypotenuse, which is C. And then tangent is opposite, B over which is A. Okay. How on earth are we going to remember? You'll hear this over and over and over again for probably the rest of your life. So, ka, toa. Okay? That is your acronym for remembering how to find these. Okay? So, sine equals opposite over hypotenuse. So that's the so part. Sine, opposite over hypotenuse. Ka, cosine equals adjacent over hypotenuse. That's your C, cosine, adjacent over hypotenuse. And so your TOA is tangent is opposite over adjacent. Okay, a few things that you have to remember. This only works with right triangles. You can only use it with acute angles, and you're only going to have acute angles if you've got right triangles. Okay? And our ratio is usually going to be rounded to 4 decimal places if we're putting it in the decimal. Okay? Most of the time, we will have this as a fraction. But if it's asking you for a decimal, it's going to be to 4 decimal places. Okay? So, let's put this together with some numbers. So if I am looking for sine of A, so that means we need to look at A right here. And sine is what? Opposite, which is 8 over hypotenuse, yeah, is 17. Okay, cosine of A is what? Okay, what's the A stand for? Adjacent is 15 over hypotenuse is 17. Okay, and tangent is your TOA, so opposite, your O is 8 over adjacent is 15. Okay, so if we're talking B, we've got to look at this angle right here. So B is going to be opposite is 15 over 17, because that's opposite over hypotenuse. Cosine is adjacent over hypotenuse. And tangent is opposite over. Look at those 6 fractions that you have written on there. Do any of those fractions equal greater than 1? Which one? Tangent of B, right? There's only one ratio that could ever be greater than 1, and that's your tangent. Why? What do you think that is? You can be, yep. So if I'm looking at sine and cosine, those both have to do with what side? What's the bottom of both sine and cosine? The hypotenuse. Can the hypotenuse ever be smaller than the leg? No, because your hypotenuse is always your longest side. So sine and cosine can never be greater than 1 because your hypotenuse is always going to be on the bottom. Does that make sense? Whereas a tangent, when I'm dealing with tangent, it's opposite and adjacent, and sometimes just opposite side could be bigger than your adjacent side, right? Okay, so that's why tangent only works that way. Alright, so let's talk calculators. First thing you need to do when you are doing calculator stuff is you need to make sure you are in degree mode. Alright, so graphing calculator, you've got to hit mode. Right now my radians, I've got to go down there, I've got to go over and hit enter to turn my degree on. Okay, if I've got this guy, you just hit the DRG on the top, right next to your alpha key. Sweet. If you've got this one, same thing. You've just got to hit your DRG button. DEG for degree. All right, anybody else? On a different kind of calculator? All right, so where's the pen go? So now, get out of this second mode. It's going to get you out. So most of us are going to hit sine of 74. Some of you with the smaller calculator have got to hit 74 sine. Kind of depends on what calculator you have. And the 4 decimal places, this is going to be 0.9612. And if I'm going cosine of 74, I've got 0.756, and tangent of 74 is 3.4874. What do these mean? What on earth do these mean? What do these decimals mean? Okay, so let's talk about this for a minute. If I'm okay. That was very scary. Okay? Sine is 1 over what? Opposite over hypotenuse. What does this 74 mean? That's the degree of the angle I'm looking at. So let's say I have a triangle with a 74 degree angle. Okay? This means that no matter what my sides are, if I have a 74 degree angle, from that 74, if I divide opposite divided by hypotenuse, I'm always going to get 0.9612 if I divide opposite over hypotenuse. If I have a 74 degree angle, my adjacent divided by my hypotenuse is always going to be, what's it going to be? 0.2756. And my opposite divided by my adjacent is always going to be 3.4874. Okay, so no matter what my side lengths are, if my degree is 74, opposite divided by hypotenuse will always be 0.9612, no matter what. Okay, so that's what they mean by that ratio. Okay, I believe you that you guys can do that. Alright, I just want to take a quick peek at this. No, this one's dumb. Just kidding. And then we're not doing that part. But, okay. Looking at this one. If I had another triangle that was $30, $16, and $34. Okay? You've always got to put your ratios in those terms. would I end up with the same ratios as this guy? Yeah, why? My triangles are what? Well, they're not, yeah, they're the same degree with their angles, because what kind of triangles are they? They're not congruent, they're similar. They're similar triangles, so the ratio of my sides are going to be the same. Okay, so my angles are the same, my sides are proportional. They have the same ratio. That's why it works with all your triangles. Okay?